In this video, we're going to take a look at how to use differential calculus to find the equations of tangent and normals to a curve. Now, just to recap what we mean by tangent and normal, if we look at the diagram here, this is a colour one, a tangent is simply defined as a line which touches the curve at a particular point. So if we take P as being our point where the tangent touches the curve, then the normal is drawn at right angles to the tangent, so shown by the square there. And we know from year 10 maths that the product of the gradient of the tangent and the gradient of the normal is equal to -1. So the other thing then that we simply need to just refresh is that to find the equation of a straight line, in this case be it a tangent or a normal, we need to know either 2 points to define a line, but in this particular case we'll be using the fact that we will be given a point, or we'll need to find that point, and we'll then know the gradient. So knowing the gradient and a point, we've got our equation down the bottom there to find the equation of the line. Okay, so let's look at the example here. We want to find the equations of the tangent and normal to the curve defined as x cubed minus 2x plus 3 at the point 1, 2. Now we have half the information. We have a point, and we need to know what the gradient is at that particular point for firstly the tangent and then for the normal. Now we can simply, if we know what the gradient function is, finding the first derivative here, once we find the first derivative, if we substitute in x equal to 1, that will then tell us what the gradient of the curve is at the point x equal to 1. So if we start with our equation and we find the derivative, now remember the rule is nx to the n minus 1, so the derivative here becomes then 3x squared, so 3 comes down, subtract 1 from the power. X here is x to the power 1, so that simplifies to -2, and of course the derivative of a constant is 0. So now that we know what our gradient function is, if we substitute in the value of x equal to 1, that then tells us that the gradient then of the tangent is 1. So now that if we substitute into our general equation, we know that the point is 1, 2, so you've got y minus 2 is equal to the gradient, which in this particular case is 1 times x minus 1, and that simplifies then to y equal to x plus 1 is the gradient of the tangent. Okay, so we now need to find the equation of the normal. Now we saw at the start that the product of the tangents of the gradients of the tangent and the normal is equal to -1. So since we know what the gradient of the tangent here is, if we substitute that in, that will simply simplify to that the gradient of the normal in this particular case is -1. So since we're talking about the same point, we now substitute into the equation, the general equation. So we're going to have then y minus 2 is equal to the gradient this time is -1 times x minus 1. Expanding the brackets, we get -x plus 1, which then will simplify if we add x to the other side. So we'll have x plus y, and then subtracting 1 from both sides gives us x plus y minus 3 equal to 0. So in summary, we have that the gradient, that the equation of the tangent is x minus y plus 1 equal to 0, and the equation of the normal is x plus y minus 3 equal to 0. So you've now seen the basic theory behind finding the equations of tangents and normals. We need to know a point, and we need to know what the gradient is at that point. So the gradient will initially come from the gradient function, which will tell us what the gradient of the tangent is, and then we can simply substitute into this value up here to find what the gradient of the normal is. In class we'll look at more examples where sometimes the point in question might be where the graph crosses the x-axis, so we need to solve to find what those points are, or it might be where the graph crosses the y-axis, or we might be looking specifically to find the equation of a tangent or normal that's parallel or perpendicular to another line. So in class we'll have a look at all these other types of problems, but they basically come down to using mt times mn equal to -1 to work out the gradient of the normal, and the gradient of the tangent comes from first finding the derivative of the function.